Guys, so here we have a question, okay, which most people might think is very complicated. But let me tell you, here's a secret that makes it super easy, right? So come on, grab a pen and paper and we are solving this together, alright? This is a simple, okay, sum and we shall be doing step by step, okay? Not only this, we are doing a few more, okay, of the kind, alright? So what do you think we should do for this? Okay, because this has a minus power of 1. So can we write the reciprocal of this? So here we go. As per the exponent rule, whenever there is a minus 1, that means that this is to be written as 1 upon a plus b. Correct? There's a multiplication sign between. So let's take them separate. Here again a minus 1 thingy coming over here. So this is 1 upon a. Similarly, this is 1 upon b. Correct? Now this is our right hand side, which is what we are heading towards, right? So what should be our next step? This can't be broken any further as we have already done this. So let's just copy this. Alright guys. For this, can we do something? Yes, we can. A and B, okay, are the denominators. So let's find the LCM. Okay. So the LCM of A and B is AB. Alright. So since we have A here, so we'll have a B here, right? And a plus sign here. Since we have a B in this, so A will come over here. As simple as that, okay? Here, 1 upon AB, 1 upon AB, till we prove the left hand side equals to right hand side. This can be reassembled, isn't it guys? So A plus B here, and we can write over here as A plus B and AB below, okay? And here we have 1 upon AB. This gets cancelled with this, and thus we have our answer 1 upon AB this side, which is equal to the answer on the right hand side. So left hand side is equal to right hand side, thus proved. Alright guys, so this is how this is to be done. So let's go to the next question of the kind. So guys, this is the next sum that we need to crack. So let me say that you have 5 seconds to solve this equation. Okay, can you think about it? Let me see. Okay, just try. How would you go? Okay, any idea? So do you feel frustrated by seeing such kind of problems? If so, then I can assure you we can change today, okay? Your attitude. How will be that? Let's go. So since they have said, okay, that we need to evaluate, okay, and find out the positive value of A minus 3 by A. Remember, positive value of A minus 3 by A. They have given certain conditions that A square plus 9 upon A square equals to 31. Alright. So in that case, how do we go about? Okay. So just be there to understand this. So my step, okay, 1 would be, okay, yes, we need to square up this, okay, and as a result, what do we get? We get A square plus 3 by A, okay, square minus 2 dot, okay, 3 by A. Why so? Because we know that this is my A and this is my B, and as per the second identity A minus B whole square, this is my A square plus B square minus 2AB. Alright, AA gets cancelled. Here we have, okay, A square plus 3 into 3 is 9 upon a square, correct? And here we have 2 into 3 is 6. Did you get it? I think we are reaching the final destination, and I'm sure you people have guessed, how do we go further. So we have a square plus 9 upon a square, which is already given over here. So can we substitute the value of, this with 31? Yeah, you guessed it right here. So this is 31 minus 6, which is equal to 25. Remember, there is a catch over here. Okay, so since a minus 3 by a whole square, the outcome is 25. Okay, so therefore a minus 3 by a should be 25 square root, which is equal to plus n minus 5. And what exactly is our requirement? A positive value of a minus 3 by a. Which means, which one do we pick up? Obviously, our answer is positive 5. We reject minus 5. Okay? So have you understood? Now the third sum is coming of the same kind. Alright? So if I have to reinforce, I can say that a minus 3 by a whole square, is expanded in this way, and a square plus 3 by a whole square minus 2a 3 by a gets cancelled, and this is a square proper. 3 into 3 is 9, and a into a is a square minus 6. Got it? Since we have already a value of this given here, which is equal to 31, so 31 minus 6 is equal to 25. The catch is that we need to find out only the positive value of a minus 3 by a, right? So in that case, since this one is equal to 25, a minus 3 by a, square rooted 25 gives us two values, plus 5 and minus 5. And why do we write plus 5 and minus 5? I'm sure you have done in your lower classes, because 25 can be equal to minus 5 into minus 5. 25 can be equal to plus 5 into plus 5. Okay, so in both the cases, if we have to find out the square root, we get minus 5 from here and plus 5 from here. All right, so here we have the answer plus 5. All right, so we are coming on to the next sum. So till then, browse over this, guys. So the third question that we have before us is this, right? Now, to most of us, this may seem a little complicated, but actually in the true sense, it's super easy, right? So, and you would also say to yourself that why didn't you do, or learn this trick before? So let's go ahead. We have alpha to the power a minus b and then exponent. Okay, next is a plus b. Okay, so in this case, what do? Let's bring down alpha. Okay, so we have alpha a minus b, and this is first bracket, and outside we have another a plus b, correct? So can we not write this alpha a minus b and a plus b? All right, next alpha a square minus b square, and since they have already given that since a square minus b square is equal to 1, can we not write alpha to the power 1, and anything to the power 1 lands up being itself, right? So this is our answer. All right, guys, so I hope you have understood this. If I have to reinforce this, we have two exponential powers over here. First is a minus b, second is a plus b. All right, so whenever there is an exponent inside and outside, usually we end up multiplying both of them, which is what we have done over here A minus B inside, A plus B outside. We multiply these two. This happens to be the third identity, A minus B, A plus B. When we multiply this, we get A square minus B square. And since they have already given us an equation here that A square minus B square equals to 1. So we very conveniently substitute over here, use it up for our end. Okay, so A square minus B square equals to 1, which means alpha to the power 1, and alpha to the power 1 will end up being alpha itself. Alright, so this is as simple as this. Alright guys, I hope you people have understood. So the fourth one is coming up, so let's see how that is going to be. Okay, so guys, do you think you will be able to solve this? I'm sure you will be able to solve this, but how? So that's a big question. Okay, so how will you go? So remember, there is a twist in this, and I hope you can figure out that, okay, in time. So can you just foresee that? Okay, so anyways, let's just go about and see how we can crack this. Since they have given a division sum over here, so let's go and write 2 to the power 9x divided by 2 to the power 2x, correct? This is on the left hand side. Here we have 2 to the power 14 clearly, but it is the 7th root, correct guys? So in that case, can we write this? I'm sure we can write this. Now, since there is a division over here, so 2 to the power 9x minus 2x is the probable answer for this. 9x minus 2x, because whenever any power having the same basis, okay, is in the denominator, goes up to get subtracted by the initial power there, up there, right? And here 2 to the power 14 multiplied by 1 by 7. Clear? So far so good. Now we can easily cancel this. We get 2 to the power 2. And here we have 2 to the power 9x minus 2x is 7x, correct? Equals to 2 to the power 2. Isn't it? Now, since we have the bases same, we can equate the powers easily, correct? Which means, therefore, 7x equals to 2 or x equals to 2 by 7. So this is our answer, and that's it. So these were a couple of sums that you all did, okay, based on the powers, indices, exponents, radicals, whatever you may call it. Okay, so they were of different kinds. So in future, again, I'm getting something like that, a bunch of them, so that you can practice and be ready for your exams. Alright guys, and if you like this video, do subscribe. Okay, so that can only help me, okay, in bringing more and more such videos. Thanks a lot guys, and have a great day. Okay, bye bye. All right.